Greetings, math friends. I want to do an indefinite integration of the EML function. You can learn more about this new function at the links in the description. This is fairly new in mathematics research with applications to computer science, specifically with applications to AI. This can be rewritten as e to the x minus the natural log of y dy dx. And then we're going to focus on this inner integration first. Using our normal integration techniques, we're going to split this into two integrals separated by the subtraction. We are integrating with respect to y, so this is going to give us y e to the x minus y log y minus y. As we integrate this here, we need to use caution. This negative is going to distribute over this, so this is going to be positive here. And since we are doing a double integration without having a area declared, this is indefinite, we need to have a function of integration here instead of a constant of integration. And then this was the inner part, so we now have to integrate with respect to x to finish this out. We have multiple parts here that we can separate out into separate integrations. This is essentially a constant here, so it's just going to pick up an x as we integrate. The same for this y here. Integrating little f of x will give us big f of x. And then at the end, we again will need a function of integration instead of a constant of integration, say some g of y. So this is our result of integration when we do a double integration with an undetermined area over the EML function dy dx. One follow-up question we might ask is, if we change the order of integration, do we get the same result? Let's take a look at this one more time, but switching the order of integration and see what happens. Again, we're going to focus on this inner piece. And again, this is still defined as e to the x minus the natural log of y. And this time, we are going to integrate with respect to x. So integrating e to the x with respect to x just gives us e to the x minus, and this is essentially just a constant. We're going to pick up an x here. And we have, again, some function of integration that we pick up. And now we're going to do the outer integration, so with respect to y. So we have a constant. This is no longer just a constant here. This is a function of y. Let's go ahead and write this out a little bit. This one's pretty easy to do, but I want to look at the rest of the pieces of this. Since x is a constant, it can move through the integrand, and we can just look at this. So we're going to have x times y log y minus y here as we integrate log y with respect to y. And of course, we don't lose our y e to the x. Over here, this is just going to give us big G of y here, and as we finish that integration process, we are picking up a function of integration. So this is going to require distribution. So we're going to have y equals e to the x minus xy log y, that's all one term, minus xy, positive, bringing the negative through, double and the negatives make it positive, and then plus big G of y plus f of x. So we end the process with this. And then we have to ask ourselves, is this the same result that we got before? As you consider that, the first three terms are the same, but as we look at the last two terms, these were our functions of integration that we picked up at the end. These are just like the constants that you pick up when you do a single integration that's indefinite over some function. It just varies essentially by a constant, so we're good. I hope this has been interesting to you. I hope this has been a fun new look at a new function. Cheerful Calculations.